né? Porque eu me escuto depois de algum tempo,
É
é meio
horrível. Não,
creepy.
pode deixar, eu vou.
Não, beleza.
Acabei de tirar, inclusive. Só
Ah,
tirar
a
aqui.
gente tá ao vivo, eu acho.
Uhum. É, foi legal o- a transição. Você começou no YouTube também? Ah, tá bom. Maravilha. Então, 7 minutinhos. Sim, sim. Acho que a gente começar agradecendo, né, as pessoas, até para dar uma enroladinha para as pessoas entrarem, perguntar de onde que elas vêm, para deixar comentário, fazer um merchanzinho. Maravilha. Se quiser botar o link aí, eu já coloco na descrição. E aí, quando terminar a live, você me manda o notebook que eu já coloco no Slack. Top. Ao vivo? Acho que vale. Sim. Que é como que a pessoa faria hoje? É pelo Python, né? Entendi. Não, tá bom. Acho que só mesmo para mostrar que tem um REST point ali, né? Para explicar, aí a gente fala um pouco do end-to-end. E assim, o que eu acho legal é do tipo, a gente tentar passar a mensagem de que, cara, a gente sabe que não é simples, a gente sabe que tem um monte de erro, boa parte do trabalho não vai sumir, a ideia é facilitar, né, a vida das pessoas. Acho que faz sentido. Não tô querendo dizer que, assim, que ele nunca mais vai precisar ficar fazendo EDA, porque a gente sempre fala, olha, apesar a ideia principal é você ser capaz de gerar um modelo bom o suficiente para você colocar em produção, enquanto você se preocupa em arrumar a sua base de dados, assim. Essa preocupação não vai sumir, mas você já vai ter algo bom rodando enquanto isso, e fazendo dinheiro enquanto isso. E aí, para hoje especificamente, de repente a gente citar, né, o exemplo da. Bom, que eu coloco o telefone no mudo. Para quem é autônomo, exemplos de uso de churn, entendeu? Então, quando você tem uma contratação prévia do seu serviço e a pessoa pode cancelar ou não. Enfim, acho que a gente citar alguns exemplos onde o churn pode aparecer, sei lá. Cadê a descrição? Aqui, editar. Link do dataset. Vale. Vale sim. Fiz uma coisa hoje que eu lembrei de você. Eu fiz um chocolate quente que tá um frio do cão aqui, sem açúcar. Eu fiz com cacau em pó e fiz com. O grande truque foi colocar leite em pó, porque aí eu coloco menos água, ele fica bem cremosinho. Meu namorado saiu falando assim: eu quero que você me ensine a fazer, porque ficou muito bom e tá muito frio, eu vou fazer quando você não estiver aqui. Aí eu falei: puta, vou mandar essa pro Dionísio. Aí eu tava de gordice e resolvi colocar um tiquinho de creme de leite junto. Mas também não adiciona açúcar, né? Adiciona gordura. Ficou bem bom. 500 o quê? Pá. Bem, bom sinal. Qualquer coisa a gente só não mostra essa parte e já avisa, né? Ah, tá. Exato. Uhum, uhum. E maravilha que deu a hora já também. Ó, Gil, o áudio do YouTube tá aberto. Não, a gente acabou de. Tudo isso que a gente acabou de dizer. Tá bom. Só pra constar.
with Laura. So Tayan's here. So they should be here, yes.
So everyone, this time we're going to do our Hey Jay on a different topic. This time a classification problem. We had 3 regression problems in a row. So I'm guessing this time you'll be able to see something a bit different. And we decided to talk about churn cases because we had some increasing demand for this particular problem, both from autonomous and freelancers regarding network trafficking to predict churn prediction in network trafficking data, also from automobiles. Oh God, forgot the word. When you can you help me, Dionisio?
Rental.
Rental. Thank you. So when you rent
a
your
car,
and also for big industries in which you have big customers and they make huge impact when they churn. So that's why we decided to talk about this subject today.
Yeah, and also, I mean, churn is one of those problems that almost every company faces. So like demand forecasting and churn is something that is almost ubiquitous among companies. So you always really want to know if your customer is about to leave you, is about to cancel your subscription or just stop buying. And then the definition of churn, of course, depends on the business that you are into. So churn is a very important problem that you can actually solve with J, and you can actually make it happen very, very easily and very robustly with our framework. That's what we want to show you today. So may we go right into the data?
I guess so. Tayan said I was muted. I'm not sure if I'm still muted.
Yeah, probably not. Probably not, because I had a toggle, the wrong way before, but
okay,
it should be right now.
Perfect. So let's go to the data. And guys, if you had any questions, please feel free to write in the comments. Also, if you're watching this after we publish the live, you can also ask at the comments and we'll take a look and answer you right back. We also have linked in the description the link to the data set if you want to try it for yourself. And if you want access to the notebook that we're presenting here, you can get it into our Slack community. The link is also in the description. So that's it.
Yeah, and everyone's very welcome in our Slack channel. So we're talking about not only J stuff there, but we'll be sharing a lot of insights and tips and even some memes about machine learning, AI, and how to make these things work. So, and we're very glad to have you here. So let's get into it. So as you are already familiar or not, so I'm going to quickly talk about J. So J is a machine learning framework we've created to really make the process of getting machine learning into production very easily and very straightforward. And our focus here is on productivity. So although you can experiment a lot with J, you can try a lot of different hyperparameters, you can keep experimenting and trying different things with J. We have built J with productivity in mind. So if you have a problem and you want to predict churn, today you want to classify your customers into more prone, more willing to churn or not, then you should be able to do that and to accomplish your task, straight in a more straightforward way than trying to gather all those different frameworks and all those different Python packages to make things happen, and then you also try to find your way into getting your model into production. So what we really want to solve with J is like getting end to end. So you have your modeling and your deployment all in one big framework that we call J. So using J is installing J is very straightforward also. So you just pip install J SDK into your computer. You can generate you import J also, and then you can generate your own auth key. So it's a very generous free tier. You just do j.get auth key, and then have your email, your first name, and your last name. So this is enough for us to email you your key, and then you can just get started with J and do all the things. So it's very straightforward, and we promise your privacy. This is just to make sure that you are not a bot, and you're going to receive this email and use your key to make great stuff come
This is
true.
actually a great point, because if you write a wrong email, since we don't check it and don't send spam or anything like that, then we won't know. It won't pop up an error or anything like that. So be sure to write your right email.
Yeah. Yes. So let's go. So we have J now instantiated here. I'm going to read this data set. Let me just split these cells right there. So this is a quite standard, I guess, churn data set. It comes from Kaggle. Probably we'll have the link below if you don't already have it. So it's a quite standard data set in the sense that you have each line is a customer. So you have several customers. In this case, you have 7,000 customers, and you have a lot of attributes for each of them. So you have, in this case, gender, whether it's a senior citizen or not, whether it's a partner, whether it has multiple lines. So this is a user data set for a telco. So it's a telecommunications company. So you have, does this user has already bought this service or not? And there are 21 features to kind of describe who the user is. And the main thing here is how do we leverage this data in an efficient way so that we can predict whether this customer has churned or not, will churn or not. So in this case, this is like a Kaggle data set, so it's a little bit easier in the sense that it already has a column that says churn yes or churn no. Usually you don't have that in your company. Usually you have to kind of work your way through the creation of the churn column, where you classify if this is a churn or not. If you are in a subscription business, this is much more straightforward. I mean, if someone kind of has quit, then it's churn because it has stopped using your product and went away. But if you have kind of a consumer goods business, then it's kind of tricky defining what is churn. So a user has churned if it stopped buying from you from like in the last 3 months, 6 months. So you have to also work your way out to what churn means to you. What kind of churn are you willing to measure and predict with your model?
Perfect. So there's another point in there that since it's a Kaggle data set, you also have the columns that they find are more important to predict the churn in this case. In your case, and that's something we like to do with J, focus on what you know it's important to you and to your company. For example, if you were doing traffic management, maybe a customer put your product in their chart but never bought. Or maybe someone bought something from you and then didn't renew the subscription, for example, if you were into a subscription business. So you have to build not only the label, but also which columns you find more important in your case. Is the amount of time without buying anything from you? Is the amount of time the person spends watching a video from you from YouTube? So you have to decide in your case for your business which features you have or which features you might build that can help the model in this particular task. On the other hand, you don't have to worry if you have a typo or a duplicate or something like that in your data set, at least not in the beginning, but we'll get back to this point during the live.
Yeah. So the main thing that you really want to notice when using J is you really don't need a lot of, and sometimes any pre-processing. So this is a data set that you have clear categorical features like female or male for gender, and yes or no for partner, and you have also clear numeric features such as monthly charges and total charges. Ideally you should pre-process this data to kind of normalize, make them have zero mean, one standard deviation, things like that. When using J, you usually don't need to do that. So we're basically just checking the data types. This could be very important. So the majority of the features are strings, they are objects, the Python objects, they are just text. And then the monthly charges are a float. So you expect a variable called monthly charges to be a number, and you also expect total charges to be a number. So when we try to understand, well, there's just one line of this data set that has this blank value instead of a number, and this prevents the total charges from being a numeric column. So, and even if you run J on top of it, using total charges as an object, it wouldn't really be a problem. J would solve that inside, but just for the sake of like the cleanness of the solution, we'll first replace this blank space with 0, and then apply numeric conversion, casting it to a float also. So when we now check the data types, we all have total charges as a float too. So this wouldn't be really a problem. It's just to make, if there is one thing that you should pay attention is the type of the variables. So when using J, and I'd like to build this J setup with you very slowly. When using J, what we are really doing is getting raw data and using machine learning models to transform this data into vectors, meaningful data representations, and then using those representations for prediction. So in this case, we really want to run a J setup. So let's just build it together. So every time we use J to create a collection, to do something, we always use J setup. This is our core method. So I'm calling J setup. I'm saying, my collection name, which is also kind of the model name, is so telco live. It could be anything. The data that we are passing is the data frame itself, so it's really this data set. Now notice that we have a customer ID column here. A customer ID probably wouldn't add any big information to the prediction. So we can leave it there or we can remove it. So again, kind of for the sake of let's make things a little bit bright and be a little bit more cautious. We're gonna drop this customer ID column because it doesn't really add anything to it. So this data set, we drop the column, drop customer ID. Okay. What you also want to do when you're calling JSetup is to say to J what kind of data are you processing or what kind of task are you trying to do. So in this case, we want to do a supervised classification. So the DB type, the database type, the collection is going to be supervised. And because it is supervised, that is because we have a clear goal here, which is to classify customers into churn or not churn, and to predict ahead of time. So we have a label. So if we have a label, we have a supervised problem. And we are now saying label and the label name, which is again churn. Remember that this is a binary variable, which is in this case, I guess yes or no. Let's check. So okay. So it's a binary variable, which is yes or no, and then we want to classify it. So the name of the label is churn. Now the task that we are performing could be regression, quantile regression, and also could be classification. So that's what we're going to do today. We're going to do metric classification. But it could also be, we won't get into it today, but it also could be image or text or fast text or edit text.
Our documentation is also linked in the description, so you can access it if you want more details on every type of training possible. You can also check our previous lives. They are also linked down below, and you can check different ways of running J if you like.
Yeah. So the only, I mean, I guess it could be right. This is a complete JSetup setting. What I really want to mention besides that is auto learning rate. So you have a lot of things to worry about when you're building your model and you're building your data set, and the more you can just stop thinking about some things, the better, right? So I really don't want to kind of keep tinkering and trying different learning rates for our model. So I'm just going to set it for auto. So we do this by doing hyperparameters, and oops, this is okay, and learning rate, and setting it to 0. So okay. So learning rate, 0 learning rate for J means auto learning rate finder. So you really don't need to worry about it. It's very efficient. So, with this in mind, we can just kind of run it. And what do we expect? So let's just. I'd like also to add variables equals true so that we can see the loss when the training ends. And I'm going to leave the override equals true in case we want to run it again. Okay, it's DB type. Yeah. What J is doing right now? So the first thing is insert data. So your data is going to be sent over to J servers. So you don't need to have any specialized hardware in your computer. You don't need to have GPUs or a lot of RAM memory or high-end processor. You really don't just need J. So we're sending data to our servers where we have all this stuff already working in high performance, and there we have a very state-of-the-art neural network working towards metric classification, and we can get a little bit in the details why we are using metric classification and what this means. It's kind of a contrastive objective function. It's much more modern than traditional just cross entropy. So we are using really state-of-the-art machine learning here to make things happen. But most importantly is that we have already baked very good best practices into the J pipeline. So when you send your data over to J, we are splitting your data into 3 parts: training data, validation data, and test data. Why is that? Well, we want to make sure that we are really optimizing for training time. We really don't want our GPUs or your time being spent on and training that's not adding value. So we like to do early stopping. Now, if you do early stopping based on your loss, you are already having like a peak ahead in your data. So it's kind of a leakage. It's not the worst leakage that could have in your data, but it is a leakage. So in order to have a more robust and a more reliable model in place, we use, of course, the training data to train a model, and then we use the validation data for the early stopping. So when the validation data starts getting worse, we stop the training. And all the metrics, all of the performance metrics that we report are being calculated on the test data set, completely separated from the training and the validation. And this is, when you're working, this is kind of a cumbersome thing to do, and a lot of times we just split data into two separate parts, training and validation. But really the best thing you can do, and mostly if you're doing any kind of performance optimization, hyperparameter studying, early stopping, you really want to do the splitting into three main components: training, validation, and test. And so, don't think about it. Don't even think about not doing it. We'll do it for you, and it's done. So,
exactly.
So Jay,
that's a very important point for us, because we had a lot of expertise into consultation, machine learning for enterprise. So we know how difficult it is to deal with messy data and doing all the EDA and the ETL, so you can have clean data before you put it through your model, and also worrying about how the model is being built, which activation function to choose, which validation score, which metric, what are we going to do? So we know how hard and how difficult it is, and we also know that we do have to pay attention to all those details in order to have a good result in the end. And not only that, but we also have to worry about how to communicate these results so the business will buy our idea. So our idea with Jay is, how can we make this at least a bit easier? Because you still have to collect your data, you still have to think about how to solve your problem, to think about feature engineering and best practices in other things. But with J, you don't have to worry that much about which model I'm going to choose and which activation function, which hyperparameters I'm going to tune. So you don't have to know all the PyTorch, Keras, and everything, libraries and documentations in your head in advance to be able to run this kind of model. So that is one of the core ideas of J, that if you're an expert, you can build even more things with J and do different hyperparameters tuning, and also different, put your extra sauce, the things that you've learned along the way. But if you're a beginner, you don't have to overthink that you don't master all these documentations of all these libraries. And you also don't have to overthink if you're going to have the architecture needed to run a deep learning state-of-the-art model in your own machine, or even in Colab, or even in your client's machine, if you're using J to build models for others, for example. So that's one of our main concerns, that it's simpler to use, simpler to understand, and to explain to others. And even if your data set is not as clean as you like, you can have a working model good enough for you to put it into production, but while you clean your data, because clean data is always going to be better than dirty data. So you have this time to clean your data lake, to check inconsistencies, but while you do that, your model is already into production, generating value to the company. That's the main idea.
Yeah, and also remember that because we don't have to do the all the pre-processing, we really don't have to make sure that you have all your categories standardized, and that you don't have a typo and things like that. You really don't have to worry that much about it. You can just gather more data and use it in your models. And because the way of the way the J works inside, and making this raw data transformation into vectors with representation vectors, representation learning, it is just going to be much more robust, and in the end it's just going to work. So this is our training loss, and as we said before, the training stopped early because of the early stopping criteria, and this is it stopped at epoch 23, and this is our performance metrics for the churn classification. What's really important here is that the first thing is you can actually trust this performance metric, because like I said, we guarantee that this is being calculated on top of your test data set, so there's no leakage in that. Another thing that is really interesting is other metrics that you can explore with J. So if I can do a report, J report, and what's the name of our model? Oh, telco live. So telco live and return report equals true, so that we get the whole thing. But this is your standard classification report. So you have your precision, your recall, your F1 score, your overall accuracy. If you check on others' work in Kaggle with this data set, you're gonna see this is like the state of the art or very near state of the art. It's a very good result, overall result. And we spent like some minutes to get it done. So, and we're not bragging that this is an AutoML super black box that you close your eyes and it works. But we're saying is that if you don't have the time to keep tuning your models, or if you don't want to, or if you don't know how to do it, you can't trust the best practice and the data transformation that happens inside J. So that's what we're telling you. And we are also telling you, look, we have some pretty modern stuff baked into it. So metric classification and contrastive learning has been really, in a supervised setting like this, is something really, really novel. Kind of like 1 year ago it started happening. And it's already fully working inside J and making your results much more robust and calibrated. So this is the report, like I said. So it's a dictionary, you can get its keys. And so, for instance, if you want to know, okay, so in what are the customers that we evaluated our model against? So this is going to be our evaluation IDs. So if I have report of the evaluation IDs, this is the IDs, and then I will just index on our data set. So right here. So these are the customers that were into our evaluation phase and the metrics. So as you can see, they're here. I mean, it works. So if you wanna check who went into the validation phase, we can use, of course, the validation IDs and do the same thing. As we use the okay, so another thing that I like to check is the baseline models. So this is a classification. It's always nice to check whether how would baseline models would perform if you were not using deep learning. So if you are just shooting for stratify is like you are just repeating the same proportion of churn that happens in the past, and you're just repeating this as your prediction. You would have something like this with this accuracy and this overall performance, and we can check that having a machine learning model went better than having just this baseline. And the same happens with if you just said the most frequent class, which is no, right? This customer won't churn. And even so, even if you say this customer won't churn, and then of course your precision for the no class is gonna be higher, but your overall accuracy also suffers. So your overall solution quality using a machine learning model is much, hopefully much better than just using your baseline metrics. So it's always a good practice to do that. Another good practice is that we should remember that when we're talking about classifications, we usually have a threshold. So you're predicting a probability of a customer being either in class 0 or class 1. Being in class no, it won't churn, or being class 1, yes, it will churn. and usually what we do is just use a half 0.5 as this kind of standard threshold, but there is no particular reason why this should be optimal to either classify someone as churn or not churn. So what J also does for you is to calculate the optimal threshold. So, okay, in this case, it is exactly 0.5, but actually usually it is very different than that. So, but in this case, it was, so we can trust our results very straight ahead. So this is kind of the main thing about using J.
I would like to say just something else on the optimal thresholds.
Sure.
The optimal thresholds tend to optimize the F1 score. So we entered a competition with J in which they were using the F1 score as a metric for the contest, and well, we already had the way of working around this. So that's something important, especially when you have unbalanced data and maybe you don't have as much data as you wanted. So that's very nice thing to watch in case, I don't know, maybe this number would be like 60% or maybe 55. In this case, it was exactly 50%.
It was really unexpected, to be honest. So
yeah, you see that we are running this live because we didn't check
it's never equal
earlier. So that's unusual. We know that. You probably know that too. So that's why we put the optimal threshold. So in this case, you can use, you have better information and more information to make better decisions. That's the reason.
Yeah. Also, this collection now is in your, so if you have your own key, you can just do like j.info and gather all your collections and in more details about it. So, oops, I should have assigned this collections. So my J collections comes from JInfo. Oh, it's J Live actually. Telco Live. So my collections. It's just a standard data frame, and we're looking for Telco Live. So here it is. So Telco Live is now a J collection, which is of the type supervised, as we saw earlier. It has been modified right now. It has zero dependencies, meaning it is not being fed by other J collections. So you can see in our documentation or in the other lives that we were always feeding the models with another pre-trained J models. You can't do that, so it's gonna be listed here in the dependencies. For this data set particularly, we don't have any dependency. We just went straight away with the supervised model, and we have the same number of data rows we have of vectors. And speaking of vectors, what are our vectors? So if we have j.download vectors and we download Telco Live, yeah. Let me delete this. Oops. Okay, so what we have here is we have transformed our data into vectors. So instead of 7,000 so from 7,000 customer rows with 21 features, we now have a dense representation of 7,000 customers, but with a dense representation with 64 dimensions. So this is the representation of customer in the classification context. So these vectors, they are a very good representation for classifying customers in churn or not churn. So they're not pure representations. For that, you should use a self-supervised DB type in J. So if you were looking for a pure and the best representation possible for the customer itself, and for similarity search or for using it as a feature for another model, you use here as self-supervised, and then you don't have a label, and then you have a nice customer representation vector. But since we run all the data, all the features directly to a supervised model, we now have a vector that also works as a customer representation, but it is already a classified representation. So when we use our embedding plot library here, which is by MDE, I don't know if you guys know this library. It's a very, very nice library for embedding dimensionality reduction, and then you can plot it so you can see your classes. And you can install it with pip install by MD. It's a very, very nice library. So let's try to visualize our embeddings. So I'm just, I had downloaded our vectors here, like we showed to you, and now I'm just going to run on PyMG so we can kind of visualize our classes. Because we have used a metric classification, what our algorithm tried to do is to make sure our customers in the high dimensional, they're the most further apart if they have different classes, and they are really close to one another if they're from the same class. So we are really doing contrastive learning here while we are classifying the data. So we really should be able to have a nice plot. So let's take a look at it.
Exactly. And if you now maybe you understand why we have that much vectors, plotting in vector embedding publications on our social media. So if you don't follow us on either LinkedIn, Twitter, or Instagram, maybe you can check it out. We talk more about this, especially in the previous lives too, in which we wanted to separate first from self-supervised learning, as Dionisio said earlier. But now we are separating them, but we're telling Jay that we want them separated based on their label. So that's what he'll explain now with the graph.
Yeah, and the main thing about it is that we're really going for a data-centric perspective on machine learning instead of a model-centric. And going for a data-centric means we want good data representations. So the main is of course some mix-ups. It's not perfect, but you have those clusters of different assignments, class assignments further apart in those kind of macro clusters, as you can see. So this is metric classification working in practice, and this is how we can visualize them. So we really have clusters of data, and then this is super helpful for debugging your model and understanding what variables makes those clusters apart. So what other variables are making these customers belong next to each other right here or right there. This is a very interesting way to analyze and go much deeper in your data than just running your model. And in our opinion, it is also, just as helpful as doing your standard EDA, your exploratory data analysis. So it's very nice to look at the raw data, so we can all read the customer age, and we can all read where they are from, something like that. But when you translate things into a higher dimension, and then you get them back into a two-dimensional, and you start using colors and using visual tools to identify clusters, you also have a much more, you also have a rich understanding of what's going on with your data, but in a much more nuanced and complex way. And that's why we work with embeddings. We always translate data into vectors, which is in this case the same as the multidimensional embedding, so that we can really extract the most of your data. So, and we have used here the PyMDE. You could have used the TSNE or UMAP. It's up to you. You have the same kind of results. Everything should work very well. So, yeah. And by using J, what we really want to also show you guys is that it is an end-to-end framework. So we started with your model, your questions, the things that you really wanted to solve, and you end up with a model in production, a model that you can use, vectors that you can again plot and see how they are separated from apart. So you have those clear clusters of yes and no in this case, which you can further investigate. And also you can just consume this model and integrate with other applications in your company by using the REST API. And for that, you should take a look at our documentation, take a look at our previous live events. And but this is already live. This model is already live. It's hosted on our infrastructure, so that you can already integrate it with its API for prediction, for similarity search, and you can already use it in production, to be honest. So it's really end-to-end in the sense that you start with your problem and your modeling, and you end up with a model in production ready to be used and to generate value.
Exactly.
That there is.
I'm wondering now how. Okay, now I trained my model. I know the metric is good. Everything works fine. But what if I want to use future data? How can I do it for prediction and use it live?
Yeah, and for that, the first thing is that you can always check. You can always check your model. In detail, what the fields are, or everything that really was used in your model by calling a method called j.describe. So you can just call j.describe and call your model name or your collection name, which is in this case Telco Live. So let's say collection details. So again, this is really not a super high level black box tool. So you really have access to everything that happens. So the D-type, version, hyperparameters, the batch size, the learning rate, which kind of encoder, decoder, and every and each one of those hyperparameters you can use again in the model for kind of testing different things and see what works best. We are very confident. We have very robust defaults, but you can always tune your model by changing hyperparameters and things like that. And also on a feature level, you know exactly what kind of processing has been done, what kind of so for instance, senior citizen, it's an integer variable. It has been also embedded in a space of 8 dimensions. It has been scaled with scikit-learn standard scaling. So you really have access to everything that happens. So the churn is the label. We used in the metric classification. The classes available were no and yes. The split, so it was a random split. It could have been a stratified split, so it probably would have been better in terms of performance if we use the split, the stratified split, because this is kind of imbalanced data set. So we use 20% of the data for the validation data and 20% more for the test data. We also could have reduced or increased the number. So by using JDescribe, you have all the the small details, the everything that you need to characterize to understand what you have built. So J works by being easy, but it's not a black box for dummies tool that you can't really J grows with you. So if you keep getting more sophisticated, you want to try different algorithms and you want to use different techniques, J grows with you and allows you to try all those different things while staying in this kind of easy and protected framework that you don't have to really code again and again the same layers, the same dense layers, and the same things that has already been solved by other people. You can go straight into your problem and just try to solve your problem better and not trying to make things work from scratch, which is much more difficult.
Exactly. And if you still have questions regarding any of those items in the description of your own database, again, you can get in touch with us, especially by Slack. We are there 24/7. And the link is down below in the description if you want to check it out and join our Slack community. And you have all those, you not only know everything that happened to your training, you can see what are the options to each one of these hyperparameters in our documentation. And also, we are soon to be open source. So you're being able to see our code behind soon.
Definitely. And you should definitely join our Slack, talk to us, share your feedback, generate your key. It is a very, very generous free tier. You can try a lot of things, generate a lot of models, and get back to us. We'll be very, very happy to help you get your problem solved and using J for getting into production and generating value with machine learning.
Exactly. Can you imagine how fast you can build your portfolio with J? I mean, you just choose a business problem, you just choose the main industry in which you want to work, and start building. Just let your imagination flow. You don't have to be extra specialized to run your model with J. Imagine that today you are working in I don't know, a specific industry, and tomorrow you change jobs and you're in a different industry, and you have to be able to transfer your skills from one place to the other. And J also allows you to do that. And imagine that now you have to learn about computer vision, and then we have just a change into J setup, you can just change the D type from supervised to image, and then boom, you can already pass your image through J. You can combine different flows of data. So if you have a image from your product, for example, and also a database describing that product, you can combine these informations with J.
Yeah.
So that's one of the powers you have in your hand. You can dream about a model, and without having the nightmares of running through all the documentations, all the details, and oh my God, I'm never gonna finish this one model. So that's the main goal with J. You just have an idea, collect your data, and see what you can build. We like to do that. Just take a database, anything that it's in your interest, and try it. And if you have any trouble generating your key, or if you have any doubts, and if you're unsure about doing that, you think you lack skill or something like that, just get in touch with us and we'll help you out.
Yeah, that's it. So, and guys, thank you very much for everyone's time to be here with us today. It's a pleasure to talk about J. We always, if you just leave us here, we're gonna be like for hours talking about J and speaking about the J possibilities, what you can build, what you can deploy. But I mean, it was very, very good to be here with you today. We expect to see you again in our next live. We expect to see you in our Slack. And that's it. Let's go for it.
Exactly. So if you want to suggest a different topic for our next Hey Jay, you can put it in the topics. Also, for everyone who's on our Slack, you can choose your data set of your own and send it to us, to our Slack, and we can use your data set on our next Hey Jay. It would be a pleasure. And also, if you have questions, insights, or anything, just get in touch. We are here to talk to you. All the links are in the description again, and we'll see you guys soon.